Section 6.4, example 4 on page 453, we have all the properties of integer exponents apply to rational exponents. Let m and n represent rational numbers. Assume that no denominator equals 0. If we have a to the m times a to the n, we get a to the m plus n. For example, 8 to the 1/3 times 8 to the 2/3 is equal to 8 to the 1/3 plus 2/3, which would give us 8 to the first power, or 8. A to the m all raised to the nth power is the same as saying a to the mnth power. For example, 5 to the 1/2 raised to the 4th is the same as 5 to the 1/2 times 4, or 5 squared, which gives us 25. AB to the m power is the same as saying a to the m times b to the m. So if we have 4 times 5 raised to the 1/2 power, that's the same as 4 to the 1/2 times 5 to the 1/2, or 2 times 5 to the 1/2 power. A to the negative m is equal to 1 over a to the positive m. For example, this should say 9 to the negative 1/2 is equal to 1 over 9 to the 1/2, which is equal to 1 over 3. A to the m over a to the n is equal to a to the m minus n, so you can subtract when you have division. 7 to the 3/2 divided by 7 to the 1/2 is the same as 7 to the 3/2 minus 1/2, or 7 to the first power, which is just 7. A over b to the m power is the same as saying a to the m over b to the m. So 5 over 27 to the 1/3 power is equal to 5 to the 1/3 power divided by 27 to the 1/3 power, or 5 to the 1/3 power divided by 3. Recall from lesson 6.2 that you simplified products or quotients involving radical expressions only when they had the same index. However, you can combine radical expressions with different indexes if you convert them to expressions with rational exponents. For example 4, we have what is the 4th root of x cubed divided by the 8th root of x squared in simplest form. We can rewrite the 4th root of x cubed as x to the 3 over 4th power. The index becomes the denominator of the exponent. Same idea gives us x to the 2 over 8th power from the 8th root of x squared. Now we can simplify 2 over 8 as 1 over 4, and then on the previous slide we saw that when we divide the same base we can subtract the exponents. So since we have a base of x in the numerator and a base of x in the denominator, we can simply subtract the exponents, which gives us x to the 3 over 4 minus 1 over 4 power. 3 over 4 minus 1 over 4 gives us 2 over 4, or 1/2. And we know that the 1/2 power is the same as saying the square root. So the simplified form of this problem is just the square root of x. The work for this problem is on the next slide. And now I would like you to try number 9. Find each product or quotient. We have the 4th root of 18 times the square root of 12.